Welcome to today's Explainer, where we're going to transform the simple, everyday act of breathing into an absolute epic microscopic adventure inside the human body. Think about it for a second. From the moment you were born, your body has been performing this continuous, rhythmic action pretty much without you ever having to consciously direct it. You're literally doing it right now as you watch this. In this Explainer, we're going to unlock the incredible biological machinery running quietly in the background of your life. We're taking a really close look at respiration, the true process that keeps us alive.
So why do we breathe? It's a question we almost never ask, right? Mostly because the action is just so incredibly automatic. You take around 20,000 breaths every single day. But why? Well, the answer goes way beyond just getting air into our lungs so our chests can rise and fall. Getting air inside is really just step one of this intricate, highly coordinated operation. The real reason we breathe is to fuel a deeply complex, microscopic process happening trillions of times over in literally every corner of your body.
Okay, let's dive into this and kind of redefine what we think we know. Respiration isn't just the physical act of inhaling and exhaling. That's actually a massive misconception. Respiration is the ultimate biological engine. It's the process by which our body takes in oxygen and actively uses it to extract and release energy from the food we eat. Imagine oxygen as the key that unlocks the caloric potential of your breakfast. Without that oxygen, the food you consume is basically useless.
This master storyboard beautifully illustrates our complete roadmap for today. It captures the entire orchestrated operation of human survival, starting from a curious boy taking a single breath of air, moving down through the intricate branching pathways of the lungs, and going all the way down to a microscopic cellular powerhouse where energy is quite literally created. We're going to break down every single panel of this incredible process.
So here is our agenda for today. First, the breath of life. Second, external versus internal respiration. Third, the journey of air. Fourth, the alveoli gas exchange. Fifth, cellular power and energy. And finally, fueling the human machine.
Section 1. The breath of life, the spark of survival.
Section 2. External versus internal respiration, a tale of two systems.
To truly understand this life-sustaining process, we really have to look at the spark that starts it all. Everything begins with our immediate environment and our body's urgent, unending demand for an invisible gas surrounding us. Respiration actually functions as both a sprawling delivery network and a specialized power plant. On one side, we have external respiration. That's the mechanical, outside trade of gases with the environment. It's the physical drawing in of oxygen through your nose and lungs and the pushing out of carbon dioxide. On the flip side, internal respiration is the inside job. This is the precise moment when your cells actually take delivery of that oxygen and use it to ignite a chemical reaction to release energy. Basically, you can't have the cellular power without the mechanical delivery.
Section 3. The journey of air, the anatomical highway. Let's track a single oxygen molecule as it gets sucked from the room you're sitting in right now. It makes its physical descent down into the human body. It enters through the nose or mouth, which act as the primary gateway. Then, it shoots down the windpipe or trachea, functioning as the main anatomical highway. After that, the road forks into the bronchi, leading right into the left and right lungs. From there, the pathways branch out even further into thousands of tiny microscopic tubes called bronchioles. They look a lot like the branches of an upside-down tree. And finally, at the very tips of those branches, the oxygen arrives at the alveoli, which are these tiny clustered air sacs.
Section 4. The alveoli gas exchange, the microscopic port.
Think of the alveoli as a bustling microscopic port where literally the most important cargo exchange in your body takes place, millions of times a minute. Wrapped in incredibly thin blood vessels, life-sustaining oxygen slips right through the walls of the alveoli and infiltrates the bloodstream, jumping aboard red blood cells like cargo onto a ship. At the exact same time, the blood drops off its toxic waste, carbon dioxide, into the alveoli so it can be pushed back up that same anatomical highway and exhaled out of your body. It is a perfect, continuous, one-for-one microscopic trade. Absolutely amazing.
Section 5. Cellular power and energy, the internal powerhouse.
But hey, our story doesn't end in the blood. What happens when that oxygen, now cruising through your circulatory system, finally gets dropped off at your cells? Well, this is where the magic of internal respiration occurs. This biological math right here reveals the true climax of our journey. Your cells take that oxygen and mix it with glucose, which is the broken down sugar from the food you ate earlier. Inside a tiny cellular structure called the mitochondria, they spark a reaction. Oxygen plus glucose equals energy, specifically a molecule called ATP, which is the pure raw fuel of the human body. As a byproduct of making this energy, carbon dioxide and water are created, which your body then ships back out as waste. It's a remarkably clean, remarkably efficient biological furnace.
Section 6. Fueling the human machine. The big picture. Let's zoom all the way back out for a second. We've gone from the room around you, down the windpipe, into the microscopic alveoli, and straight into the cellular mitochondria. Now, let's look at the whole human being to see how this microscopic factory actually affects your daily life. This perfectly details why the entire process is absolutely essential. That ATP energy we just talked about, it powers everything, from the massive effort of running a marathon down to the involuntary beating of your heart. Or even just healing a scraped knee, respiration provides the raw energy required. It fuels growth, it powers cellular repair, and just as importantly, it acts as a constant biological exhaust system, removing toxic carbon dioxide waste so you don't poison yourself from the inside out.
To quickly wrap up our journey today, let's recap with these 4 foundational points. External respiration mechanically gets us the oxygen from our environment. Internal respiration uses that oxygen to unlock energy from our food. Simultaneously, toxic carbon dioxide is removed from the whole system. Together, this automated, incredibly sophisticated biological engine runs quietly in the background, keeping our human machine healthy, active, and alive.
So, take a deep breath in right now. Really, take one. Think about the incredible, life-sustaining journey that just happened inside your chest while we were talking. Billions of molecules cascading down the anatomical highway, trading places in a microscopic port and sparking cellular energy to keep you perfectly alive. Every single breath is a marvel of biological engineering powering your existence. So with all that magnificent energy you just created, what will you do with your next one? Keep learning, stay curious, and thanks for joining me on this explainer.